So hey guys, welcome back to my YouTube channel. So in this video I'm going to solve this question, that is find k closest element. So we have given a sorted integer array ARR, okay, and we have two integers, that is k and x. Return k closest integer to x in an array. So the result should be in ascending order, okay. We have to return the result in ascending order. Ascending order means increasing order, okay. So we have given an that is integer a, okay, and x. Then this is the condition of the closest what we can take, closest integer, okay. So let me explain with the help of this test case. So directly uh, jump jump into my this digital board. So let me explain this. So if so yeah, that's so this is our array, that is 1 to this is given in sorted order, okay. This is given in sorted order, and this is, and we have to find the this k k closest element, means 4 closest element uh, to 3, okay. This is the element to which we have to find the closest element, okay. So we have to, in this example, we have to find the closest 4 closest element, 4 closest element to element 3, okay, to 3, 4 closest element to 3, okay. So closest elements means that if we do the difference, or we can say closest element means uh, the element which have a distance less than, okay, less than uh, if we do the difference of this element, that is x, from this all the elements, and whose difference is less, means that which indicates that it is closer, okay. It is closer, okay. So let's say if I do the difference between these one these elements. So 3 minus 1 will be, that is 3 minus 1 will be 2, and 2 minus 1 will be 2 minus 3 will be 1, okay. 3 minus 3 will be 0, and 3 minus, that is 3 minus 4 will be 1, and 3 minus 5 will be 2, okay. So now we have to find the first k closest element, means first 4 closest element. So I will take this elements, okay. So and this element will indicating these values, okay. These are mapping with these values. So I have to return 1 2 3 4, okay. So these are the closest value, okay. So we have to simply return the first k closest element, okay, to the given value x, okay. So in this case we have x equal to 3, okay. So we have to give the this 4 closest element to this element, that is 3, okay. Closest elements means the the lesser the difference between the element to the closer value, the lesser will be the this closer value, okay. So closer value means the distance is less than, if means it is uh, closest value means it is neighbor it is neighbor of this two, or in the question we have given the definition of closer value. So let's uh, so the definition of closer value means if we do the difference between this integer a, and a is closer to x than integer b. So the distance, the mode of distance between a minus x will be less than, should be less than this b minus x, okay. So So let's so closest means nearest or most approximate space or time, you can say close value. Okay, so it is simply means any element which is neighbor, or we can say nearby or closest. So this is extracted with the help of this difference. So how we will proceed this question? So what we will do, simply we will take this element, that is x. Okay, take this element, this is x. Okay, and do the difference between these from this from these array elements to the this x. Okay, so what I will do, simply I will take vector to vector of pairs. Okay, vector inside pair inside vector. Okay, I will take pair vector of pair to store the difference, that is the first integer will be denoting the difference. Okay, this first value is denoting the difference, and the second value is referring to the this the element from the this array. Okay, whose difference is storing in the first index. Okay, so we will take the vector of pairs. Okay, vector of pairs. So the first element will be denoting the distance, or we can say difference, and second will be denoting the element. Okay, element of the element of the array. Okay, so I will take the simply I will take the vector and pairs, and simply what I will do, make the difference. Okay, make simply do the difference between this x from the this element I, that is the array elements. Okay, so 3 minus 1 will be 2, so 2 comma 1, and corresponding element will be 1. Okay, so 2 comma 1 will be stored in our vector. Okay, then 1 comma 2, then 1 comma 2. Okay, then we have 0 comma 3, then we have this 4 comma this 1 comma 4, and 2 comma 5. Okay, two comma 5. Okay, so now what we will do, simply sort this pair this vector of pairs according to the difference. Okay, what I will do, simply sort this vector of pairs according to the difference. Okay, so simply this the differences whose that is first will be this 0 comma 3, second will be this 1 comma 2, third will be 1 comma 4, and this okay 2 comma 1 and 2 comma 5, 2 comma 1 and 2 comma 5, so 3 to 5. Okay, this is 2 comma 5. So now we have we are we have sorted this array according to the differences. Okay, now what I will do, simply resize this array according to the this k value, because we need the k closest value. So we need to resize this array, decide this vector of pairs. Okay, so simply this, because we have in the question we have given k equal to 4, so we need only 4 elements. So I will destroy this, or I will delete this last element. Okay, So now what we will do, simply traverse through this pair of this vector of pairs, and simply this 0, let's say this is 0 comma 3. Okay, so this will be how we will extract this first element, that is pair, that is vector dot, let's say this is pair p. So p dot first will be indicating this 0 value, and p dot second will be indicating this value, that is second value, that is 3. Okay, so what we will do, simply this second value will be representing our array element, so we will insert these array element. So our 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 answer vector will be this 2 3, that is 2 3 4 1. Okay, so we will store them into our answer vector. Okay, at the end we have, because we have to return in the ascending order, so we will simply reverse or we will sort this array. Okay, we will sort this array, and we will simply return this in increasing order, that is 1 2 3 4. Okay, so this is our desired output. So this is our desired output. So let me explain with the help of the code. So what we are doing here is simply we are taking an difference element. Okay, then we are calculating the absolute difference and store them in the vector of pairs. Okay, vector of pairs. Okay, after that we are sorting the vector of pairs according to the differences. Okay, after that we have to take the first k closest element, so we have to resize the difference element. Okay, after that we have taken this result vector to store our elements, or to extract the elements from the array. Okay, so we will simply, the pair dot second will be denoting the pair dot second will be denoting the elements from the array. Okay, so we will store that. Okay, after that we will simply because we have to return in the ascending order, so we will simply sort that result vector. Okay, result vector, and after that we will return that. So in this, the time complexity will be, that is we are using we are iterating first at whole array. So this is big O of n, this is big O of n. Okay, this is big O of n, where n is denoting the size of array, and this is sorting will take n log n time. Okay, so big O of n log n time. Okay, so after that we are sorting again plus n log n, so the total time complexity for this approach will be n log n. Okay, so for this time complexity will be n log n, that is big O of n log n. That the space complexity will be, that is SC, space complexity will be, that is big O of n, big O of n plus n, because first of all we are simply storing the difference along with the element. Okay, difference along with the element, and secondly we are storing the all the elements in the result vector. Okay, this is big O of n. Okay, so this is the naive approach, or we can say brute force approach. So how we will improve that? So we will using the we will use the mini heap. Okay, so we will use the max heap. We will use the max heap. So what we will do, simply we will take the priority queue and in pair, because because we need to store the difference along with the element. Okay, so simply we will take the max heap, and that any element had difference maximum, that will be come at top. Okay, and we will simply remove that top element from the min heap. Okay, after that what we will do, simply as extract the elements from the min heap that has less difference. So at the end we have to sort them in the increasing order. So at the end we have to return the result vector. For this approach, the time complexity will be, that is n log k, and space complexity will be, that is big O of n, because we are using the extra auxiliary space, that is result in the form of result vector. So these are the space and time complexity for this approach. Okay, so in this what we are doing here is, we are storing the we are using the min heap, that is max heap. So max heap has the property that the top element, the top root, or we can say root element, will be of maximum value, has maximum value. And so we will use that property here. And what we will do, simply we will store the difference of elements along with the element. Okay, difference of element along with the element. So whose difference is more, means it is it is it is it is less closer than that element, it is less closer to that element. Okay, so we will remove that. Okay, if our size is greater than k, we will remove the top element. Okay, and the remaining element, if our size is equal to k, the remaining element should be the closest element to that element. Okay, to that value. So this is the simple approach for this question. So I hope you will get this approach. So we will meet in the next video. So till then, bye bye, take care.